While I was working on this bearing assembly to make it ready for being used as a flexible component, I have found that the degrees of freedom analysis is not working correctly. I tried to do a video explaining this behavior on this assembly, but it turned out to be too confusing, so I will now do the second video, and I will walk you through the process of building this assembly, and then show you where the degrees of freedom analysis shows bad results. So basically this assembly has three components: the inner ring, the outer ring, and the intermediate part that I use to constrain parts together to get the solution that I need. I have no relationships defined now, so I will hide this. And I have now the sphere, the inner part of the bearing, and the origin part that basically is a part. So now they are free. I will now constrain the center point of this origin with the center point of the sphere. This reduces all three translation degrees of freedom, and as we can now see, this cube can now rotate in any direction. I will now constrain the surface of the cube with the surface of the sphere. So it is not moving. So basically now these constraints make the sphere only rotate about the axis. I could also just, instead of constraining that, I could also constrain the axis of the sphere with the axis of the cube. So this basically left one rotation degree of freedom. Theoretically, those two constraints over constrain the assembly, but to do it other way, it is quite complicated. But this should be okay. This is reasonable solution. Now I want to define the constraint that will fix or let me influence on the rotation angle of the sphere. So to do that, I have xy plane. I will get the xy plane of that, and I will apply the explicit reference vector angle constraint for that. So between this and that, along the either the axis or the normal of the plane. I will use normal of the plane. So I will do that 0, and now we can see that this piece has no degrees of freedom left. If I suppress that, it has only 1 degree of freedom it can rotate. I will leave it on for a moment. I will now get rid of that and get rid of that. Now I will make visible the outer ring. The outer ring is now perfectly free to move. I will assemble it as before, center to center, with the origin part. This reduces the translation, and the ring can freely rotate about the sphere now. What I want to do with the ring is to follow the rotation of the cube, so this way, and then to tilt. So I will now, to do that, I will apply axis to axis constraint with the, let's say, y-axis of the cube and the y-axis of this outer ring. This is now fixing the rotation about the axis of the cube and only allows it to tilt. Now I want to apply the range constraint for the tilt angle. So I will do that by applying an explicit reference vector constraint between this plane and this plane of the cube along this axis. I will make it 0, and now I will apply a range constraint. Maximum, minimum minus 15 plus 15. And now this outer ring is able to tilt 15 degrees up and down. Now I will apply the second constraint as before to fix it in the given position with a 0 angle. So this angle, this constraint, is in the allowable range of the other one, so everything is fine. And now the degree, there are no degrees of freedom left. If we do the degree of freedom analysis, we are getting the translation and rotation degrees of freedom for all components as 0. Now what I will do, I will suppress the rotation constraint of the cube along the vertical axis of the inner ring, and this should allow this element only to go with the cube around the inner ring. And now, as you can see, it is only allowed to go around, but so it has one single rotation degree of freedom. But if we use the inventor to tell us degrees of freedom of the component, it shows us also that the outer ring can tilt about the axis, the y-axis of the cube. This is not true because these two constraints are fixed, especially this one. This constraint is fixing this degree of freedom. This outer ring cannot rotate about the cube. It can only go with the cube around the axis of the inner bore. If we do the degree of freedom analysis, we are getting that the origin part has single degree of freedom. That is true, but we are getting not correct number of degrees of freedom for the outer ring of the spherical bearing, because it does not have 2 degrees of freedom. It can only have one single degree of freedom, that is go with the cube. So this is not consistent with the geometry as defined. I wonder what will happen if I do the animate. So it shows us that this ring can tilt. This is not true. This is against this constraint. This is not true. So basically this is failing. This is obvious bug, and this prevents inventor really from solving the assembly properly. This ring cannot tilt. This angle constraint fixes from tilting. This is wrong.